Okay, let's look at Pezzoli number 2, which is similar to Nikifor number 4, and I think Ostrov has a similar one where you're shifting and dilating and stuff like that. So let's go over carefully how to do those, because there are two different ways. There's a way that I taught you to do it, that we were doing the other ones, and then there's a different way to do it that they do. So I want to go over the two different ways, make sure you don't get confused, because if you look at their answer key, they do it slightly differently. Okay, so first we take square root of x and we want to change it so we know what that looks like, what square root of x looks like, and we want to change it to this, and we want on the domain 0 to 4. We only care from 0 to 4. Okay, so first let's graph square root of x. So I'm going to do it down here. So square root of x from 0 to 4. So here's 0, when x equals 0, y equals 0, right? So it starts at 0, 0. When x equals 4, y is 2. Square root of 4 is 2. So it's nice they did that. So let's say here's x equals 4, and then y is half that much as 2. And we know that as x gets big, square root of 9 is 3. It doesn't go up very fast in the y direction, so it's kind of curved like this. It gets flatter and flatter and flatter as we go out. Okay, so that's what our square root of x looks like. Now we're going to take this and shift it and do things to these points. Okay, we have 2 points, which is what we need, and we're going to have to shift this graph. Now here's one tricky part. This is not a straight line. So if we just shift the points, like we did in some of the problems in class, we're going to lose the shape of this curve. Like, how does the curve shape? So that's one thing we have to be pretty careful of. Just shifting the points, like where does the point 0, 0 go to? Where does the points, let's see, 4, comma 2 go to? If we just shift the points, that's fine, but if we connect them as straight lines, that's not right because they're not straight, it's curved. So we got to know which way it curves. So we got to be a little bit more careful here. Okay, so first, let's see, we know that g is square root of x, so this becomes 2 minus g is that, so square root, everywhere there's an x, we plug in 4 plus 5x, so it's just square root of 4 plus 5x, so this is our function. So if we're going to change this now, what are the different ways we shift it? We change our graph then to get this, from square root of x to this. Okay, so what I told you to do is get the x by itself first. Okay, so if you do it that way, you say y is equal to 2 minus the square root. We have x multiplied by 5, so you put a 5 there, and then that'd be x, and it's a 4, so plus 4/5. 5 times x is 5x, 5 times 4/5, 5 cancel, we get 4. Yep, that's right. And then once you do the x by itself, then the first thing you do is you dilate the x or compress it, depending which way you want to do it, which way it says to do. In this case, we're multiplying by 5, which makes it 1/5, right? It's always the opposite. So we're compressing it by 5, which means multiplying it by 1/5. Same thing. Second step is we shift it. So here we shift the x by 4/5, but it's plus, so it goes in the negative direction. So we shift it 4/5, or we subtract 4/5 from the x. Then we reflect the x. If it was negative, we'd make it whatever the point was, we'd multiply by -1. In this case, it's not, so we skip that step. Then we do the y's. So first you dilate the y, or this is horizontal. X, of course, is horizontal. That's the other way to say it. Y is vertical. So the y, let's see, is we don't dilate. There's no number in front of here. There's no like 2 there. So we skip that step. Then we reflect the y. You do that. It's negative here. So we multiply it by -1. And then finally, we shift the y. And we do shift the y, shift it vertically because it's a 2. So it goes up 2, or we add 2, same thing. This step is tricky. When we reflect the y, we do multiply by -1. So it's just x multiplied by -1. But if it looks like this, that means reflect it. If y becomes negative, it goes from being above the axis to below the axis. So a curve that looks like this will become a curve that looks like this. Okay, the curves differently. This one's curving up, this one's curving down. Okay, so when we reflect it, the y's become negative. What was positive 2 becomes negative 2, but the shape of the curve changes. So that's a tricky one when we reflect that. We got to be careful of that. So when you do all that to these graphs, you got to be careful. Okay, so if we were to do this to the graph, we would just do each of these steps, multiply the x by 1/5, so it gets a lot shorter in here. Shift it over 4/5. Didn't put a T in my shift. Shift it over, move the whole thing over, and then do the y's. So let's do that. What the heck? So multiply by, compress the x by 1/5. 0 stays in the same place. So the next one, 4/2 becomes 4/5 2. So that's going to be really short. It's going to go like this. Okay. Then we shift it to this is 4/5 now. 4/5. We shift it to the left by 4/5. So the next step is, it looks like this. That point's now on the axis. Because this is at 4/5, we shift it to the left 4/5. So that goes to here. And this point is at negative 4/5. So that's negative 4/5. And let's see, it still looks like this, curved that way. I should have made it bigger because it's hard to say. Okay, now we don't reflect it, we don't dilate the y, but we reflect the y. So multiply it by -1, it goes down here, and it keeps that same curved shape. So the next step then, I'm going to do it right here. Well, no, I'll do it over here, it's running out of room. It goes from here to negative, so it looks like this. It looks like this. You just put it down everywhere where y was positive, it becomes negative. So what it looks like now is like this, curved that way. And then finally we shift it up 2. Okay, we multiplied by -1, we switched it around the y-axis and we shifted up 2. So we take this thing, this was at 2 already. So now we just move it up to 2. So our final step is that point is right there. This point is right there, up 2, and it curves this way. Okay, if it was a straight line, it'd be easy. We just always connect with straight lines. But the curve part is tricky because we got to match the curve. It doesn't curve this way, right? It could. How do we know? So we got to do step by step to make sure that we get that curve right. Okay, that is one way to do it. That's the way we've been doing it in class. It's the right answer. It all works. The other way to do this is not to solve for x. You just go directly here. And the only difference then is you switch the order. Then you shift x first. Okay? And then the second step is you dilate the x. So if you don't want to solve for x, which is they don't because they're lazy or whatever, they don't want to solve for x, and it skips a step, you know, maybe a little bit easier, then you just switch the order of the first 2 steps. Other than that, everything's the same. The y is the same order for the y. Same order reflects last, but the only thing that's different is that you switch the first 2. Okay, so if you don't want to solve for x, you say, okay, shift x. Oh, it goes +4, which means -4. So you shift it this way 4. And then you compress it by 5. So then we compress it by 5 or multiply by 1/5. Okay, or multiply by 1/5. Then reflect it if you had to. So that's what they did. That's pretty much what they always do. They don't solve for x. They just take this form and then say, okay, shift first, dilate. So again, all we're doing is switching the order. Instead of dilate, shift, shift, dilate. And that works fine. And you could do that too. That's the way they did their graph down here if you look at the graph in the answer key. The reason why I like to solve for x is because some things are a lot easier to graph when you get the x by itself, like circles. If you get the x by itself, it's really easy to tell like where the center of the circle is. It can be easier to tell like where the vertices of functions are. It's just always better to get the x by itself, or many times it's better to get the x by itself when you're graphing something. But not always. And they just skip that step and go right from here, which you're welcome to do. Either way works. Again, this is an extra step to solve for get the x by itself. But either way works. So, and they often do it this way, so I just want to make that clear that you can do it either way. But the only difference is make sure to change the order. The order is really important. You have to do these things in the right order. And you just switch the order of the first 2. Okay, so just want to go over that. Clear up some confusion because, again, there's 2 different ways to do things. And you can do it either way you want. Okay, thanks for listening.